Hi all, my name is Sammy, and for my final project I learned about transformers, and I experienced and evaluated three of them for a binary classification problem. Let's get started. The learning objective of this project are understanding best practices for text classification with deep learning, understand text classification with transformers, and to evaluate performance of three transformer models, BERT and case, distilled BERT, and GPT-2 for a binary classification problem. This is the agenda. First, we learn about introduction, then we move to materials and methods, results, and conclusions are coming in the list. Text classification, also known as text tagging, is a process of categorizing text into organized groups. Text classification uses natural language processing to classify text and assign a set of predetermined tags or categories based on its context. Text classification isn't just fun, it's also a practical method for extracting information from unstructured data like emails, tweets, etc. It feels like magic once you analyze thousands of texts in a matter of seconds and get information like topics, sentiments, or language or whatever. It is so amazing. Today's emergence of large digital documents makes the text classification task more crucial. The increasing growth in the number of complex data sets requires more enhancement in machine learning methods to provide robust and accurate data classification. Lately, deep learning approaches have recently outperformed the previous machine learning algorithms on tasks such as image classification, NLP, face recognition, and etc. Okay, before moving forward, let's get a better understanding of machine learning versus deep learning. Machine learning is a subfield of artificial intelligence that employs techniques that enable machines to learn from their mistakes and experiences and then improve their performance. The learning process is based on feeding data into an algorithm, then performing feature extraction, then train and test the model, and use the deployed model to receive the predictions returned by the model. On the other hand, deep learning is a subset of machine learning that is based on artificial neural networks. The learning process is deep since the structure of artificial networks include multiple input, output, and hidden layers. Each layer is consisting of modules that convert input data into information that the following layer may use to perform a specific predictive task. Isn't it wonderful? Because the machine can learn from its own data processing. Okay, now let's talk about transformers. What is a transformer? Look, you can see this picture here, a picture of transformer. A transformer is a deep learning model that uses the attention mechanism. This structure is suited for solving problems containing sequences such as text or time series data. They consist of encoder and decoder layers. On the left, you see the paper Attention is All You Need, which describes transformers and what is called a sequence-to-sequence architecture. Sequence-to-sequence or sec-to-sec is a neural net that transforms a given sequence of elements, such as the sequence of words in a sentence, into another sequence. The attention mechanism looks at an input sequence and decides at each step which other parts of the sequence are important. Transformers handle sequence of data but not in a particular order. This means it can train much faster with parallelization. Okay, you may wonder, what do I mean by attention and encoder-decoder? Let me show you a simple example. Suppose a transformer is translating this sentence from English to Dutch. I am happy. In RNN, recurrent neural networks, the process inputs piece after piece. I am happy, piece after piece. But the transformer processes the sequence at once. I am happy. And with parallelization comes a lot of power to the transformer. In other words, the attention mechanism looks at an input sequence and decides at each step which other part of the sequence are important. This figure shows the architecture of the transformer. The encoder is on the left and the decoder is on the right. Both encoder and decoders are composed of modules that can be stacked on top of each other multiple times. Alright, in this project, we aim to evaluate performance of three transformer models for a binary classification, effectiveness, and not effectiveness problem. These three transformers models that we use are BERT uncased, distilled BERT, and GPT-2. BERT uncased and distilled BERT are different versions of BERT case. In general, BERT and GPT-2 are two methods for creating language models based on neural networks and deep learning. They both are fairly young. While GPT-2 is only partially open source, BERT is completely open source. What is BERT? BERT stands for bidirectional encoder representations from transformers and is a new method of pre-training language representations which obtains state-of-the-art results on a wide array of natural language processing tasks. BERT was created by Google researchers and it seems to be fully open source. And BERT is also the name of the character in Sesame Street. What is GPT-2? GPT-2 stands for Generative Pre-trained Transformer 2. It is an open source artificial intelligence created by OpenAI in February 2019. GPT-2 is supported by Transformers, the biggest open source library for AI, machine learning, NLP in Python. Data collection. For the data collection, I collected 3,823 review posts from two healthcare well-known forums, drugs.com and WebMD. I used web scraping for data extraction from these two forums. All the review posts were talking about my target medication, which is Suboxone, with the generic name of buprenorphine naloxone, which is used for opioid addiction treatments. The review posters mostly talk about the side effects, the effectiveness of the drug, and why they stop using it, and other impacts of the opioid and this medication in their personal life. They also rated the drug from 1 to 5 for its effectiveness, 5 for the best effectiveness, and 1 for the least. After data collection, it is now time to download and install required packages for computational part. For experimenting BERT, I installed two model packages, BERT uncased and distilled BERT. The uncased BERT doesn't make differences between uppercase and lowercase terms. Distilled BERT is a small, fast, cheap, and light transformer model trained by distilling BERT case. It has 40% less parameters than BERT based uncased runs and runs 60% faster than the uncased part. For the data preprocessing, the posts have been split to sentences, the punctuations, ASCII codes, and stop words were removed. Also, for BERT uncased, the texts were lowercase, and for GPT-2, the texts were tokenized using a byte-level version of byte-for encoding. For the deep learning experiments for this project, I use interactive Python programming environment, Google Colab. Google Colab is an excellent tool for deep learning tasks, which gives free access to Google computing resources such as GPUs and TPUs. For my data, for GPT-2, it took almost 2 hours to code get run completely and get the results. And for the two BERT models, for each, I would say around 30 minutes, it took to get completed. Cool experiment. After all the burden of getting the code to run properly, these are the results that I got. GPT-2 got the accuracy of 92%, BERT and case got 96% accuracy, and DistillBERT achieved 98%. And as you can see, DistillBERT outperformed the other transformers for my data. Okay, I'm adding this slide after my presentation on May 12th. When I finished my presentation, oral presentation that day, Professor McRae gave me this valuable idea that how about I compare transformer results with traditional machine learning NLP models. So without any doubt, I accepted her idea and found it very interesting. So for traditional experiment, I utilize linear support vector classification (SVC) with unigram bigram method from scikit-learn Python package. And these are the results. As you can see, for SVC, accuracy is 58, precision 94, recall 56, and F-score 71. So as you can see, there is a significant difference between transformers results with SVC, although the precision for SVC is higher than others. I hope this help my project to get a better value for future paper. I'm planning to input this comparison in my future work, of course. Okay, now we're getting to the last slide, which is conclusion, or I better to say what I learned from this project. Actually, I should say that I always had this learning about transformers in my to-do list, and I never got a chance to do that. So I'm so happy that I learned about these transformers, and I go through the conclusion. The Hugging Face package consists of a lot of models to be used as transformers. I have used 3 different transformers in this project. For the first 2 models, after transforming the reviews based on the model, a logistic classifier have been used to find out the classification results and hence the accuracy of the model. Using the combination of transformers and the logistic classifiers has increased the accuracy of the prediction, which are 96% and 98% for BERT and distilled respectively. Thank you.